Hi GOH, this is Unit 7, Lesson 3, and today we're going to talk about dilations and angles. So just a quick review again of what we already know, because this is really important. So far we know that if I take a line and I dilate it, so say I'm going to take line AB right here, alright, so I'm going to highlight that in purple, and I'm going to dilate it from a point that's not on the line. So as long as I'm dilating it from a point that's not on the line, then the image is going to be whatever your scale factor is, you times that by your original line, and your image is going to be A prime, B prime. So we always know the images of the primes. And your image, which I'm highlighting, is going to be parallel. Now, depending on the scale factor, it might be further away from that point of dilation, or it could actually be even here closer to that point of dilation, all right, depending on what your scale factor is. The second thing, which is not here, is if I have a line and I dilate it from a point on the line, then the image would just be the exact same line. So those are the things that you should be comfortable with and understand right now. So today we're going to talk more about the angles. So in exercise 1, I have angle BAC. It's been dilated with a center of D and a scale factor of 2. So I'm taking this angle CAB, right here, and I'm dilating it from point D. The image is going to be, let me do it actually in a color. The image is going to be right here, C prime, A prime, B prime. Okay? They want us to list all the parallel rays as shown. All right, I think I'll highlight the original in orange. So here's my original, and the image is in that pink color. And the point of dilation is point D. So we can see that AC is parallel to A prime, C prime. Okay, and AB, ray AB, is parallel to ray A prime, B prime. Now you don't have to take out a protractor, but I did, just so you can see. I measured angle 1, and angle 1 is 35 degrees, and I measured angle 3, and angle 3 was also 35 degrees. All right, let's come up with a reason. Why do you think that those angles are equal to each other? So angle 1 is congruent to angle 3. Give a reason based on the second property of dilations for why the angle measured does not change in this dilation. All right. If you think about it, all right, AC is parallel to A prime, C prime. Okay, so these lines, let me get out a red pen. AC, right here, is parallel to A prime, C prime. All right, so angle 1 is congruent to angle 2 because they're corresponding. And AB is parallel to A prime, B prime. Let me get a different color for that. I'll get blue. These guys are parallel. So angle 2 is congruent to angle 3 because, again, they're corresponding angles. Therefore, angle 1 is congruent to angle 3 by substitution. Okay, so I showed you why this was true. And then this is the rule basically that you need to remember. The third property of dilations is dilations are angle preserving. The lengths of the segments are not preserved. The lengths are changed by the scale factor, but dilations are angle preserving. Okay, the angles of a geometric object do not change when dilated. That is our third property that we're going to keep in mind throughout this whole chapter. So if I have triangle DEF, and it's dilated by a scale factor of 5, the image will be 5 times as big, right? I'm just doing a little visual sketch right here. I'm not making it exactly 5 times as big. Which of the following statements would be true? Is the measure of angle D equal to 5 times the measure of angle D? D prime. Is the measure of angle D prime right here 5 times the measure of angle D? Well, no. Remember, the angles are preserved. Those angles are congruent to each other, so that is not true. Is the measure of angle E 1/5 of the measure of angle E prime? No, again, the angles stay the same. Is DE the segment 1/5 of D prime E prime? It sure is. Okay, DE right here. This segment DE is 1/5 of this. D prime E prime is 5 times as big, or DE is 1/5. And choice 4, which is not going to be true either, says EF is 5 times E prime F prime. That is not true. 5 times EF is equal to E prime F prime, but I don't want to take the bigger segment and multiply it by 5. That is not true. Okay, let's flip this over. In the diagram below, triangle E prime F prime G prime is the image of EFG after a dilation of unknown scale factor with an unknown center point. Using tracing paper, verify the angles are congruent to the angles. Okay, so we're going to skip that part. I did measure the angles, all right, for us. And this angle was 90 right here. And this angle was 90. And I measured this angle was 27. And this angle was 27. And the other angle was, what's left, 63 and 63. All right, so we measured them. They are congruent. I verified it for us. Graphically determine the location of the center of dilation. Mark this point D. Leave all construction marks. All right, so here's how you do this. If you connect the image and the pre-image, okay, and you draw a line, so you need just a straight edge right here. And you do that with another image and pre-image. So I'm connecting the image and the pre-image, and I draw a line. Where those lines meet, that is the center of dilation. So the center of dilation would be right here. I can also do it for E and E prime. They'll all meet at the same point though. So that's how you find the center of dilation. All you need is a ruler. All right, using a ruler to measure the lengths, calculate the scale factor to the nearest tenth. Okay, so if you want to take out a ruler, you certainly can. I did measure them for us though. I'll let you figure out the scale factor. So I measured FG was 37. I measured F prime G prime, and that was 56. I measured EF, and that was 19. And I measured E prime F prime, and I'm doing this in millimeters, and that was 28. And I measured EG, and I measured E prime G prime. So now back from day 1, remember how I find that scale factor? The scale factor is the image, that's the one with the primes, over the pre-image. And that comes out to be 1.5. Then if I take the image, 28 over 19, it's 1.47, but again, that will round off to 1.5. There's always a measuring error when you're doing this. And the last one, the scale factor, again, image, the one with the primes goes on top over the original. That's your pre-image. And again, I get 1.51 or 1.5. All right, so we can see that all the sides have the same scale factor. So the angles are congruent and the sides have the same scale factor. All right, so knowing that, all right, we're going to be able to set up a proportion to solve for missing sides, and that's what we're going to be doing on some of the next lessons. So give a dilation that will map BC onto DE, specify both the center and scale factor of the dilation. All right, so I'm mapping BC. Let me get a highlighter. I'm mapping this purple one out here onto DE. All right, so the center of dilation is gonna be from point A. All right, so center, point A. And the scale factor, again, is image over pre-image. That's my scale factor. Right? I don't have the lengths of the line, so I'm just going to leave it like that. Image over pre-image. All right, B is just a strange question, so we're going to skip B. I should have taken that out. But I do want you to look at C, because C is something that we definitely will be doing. So AD is 10, so I'm going to put 10 on the picture. AB is 15, so this whole segment is 15. BC is 12, and AE is 14. I want to find the lengths of DE and AC, okay, DE and AC. So basically, I don't know if you guys can see this, but I really just have two triangles. I have the smaller triangle, triangle ADE, all right, and this side is 10 and this side is 14. And then I have the bigger triangle where this side was 12 and this side was 15. Okay, so I'm going to try and find a missing side. So the first side that I'm going to find, and this was BC, and this was A. Since the sides are in proportion, you can set up a proportion. Since the sides have the same scale factor, you can set up a proportion to solve this, all right? So if I call this X, I'm going to take 10 and X from the smaller triangle, and I'm going to take 15 and 12 from the bigger triangle, and then all I have to do is to cross multiply to solve. So 15 times X is 15X, 10 times 12 is 120, and if I take 120 and I divide it by 15, I get X equals 8. And then if I want to solve the other side, all right, so this is sort of like what's coming up, what's next, I'll call this Y, all right? I can take 10 and 14 from the smaller triangle and 15 and Y from the bigger triangle. And again, I cross multiply. 10 times Y is 10Y. 15 times 14 is 210. Divide by 10, Y is 21. All right? So we'll deal with, we're going to practice this all in class tomorrow.